Hi, Assalamualaikum. So today we would like to present about logical equivalence. But before that, I will introduce all of our group members. So the first one is me, Nordini Bedas Madi. The second one is Siti Zaliha Najwa binti Abdul Halim. The third is Fatima Azahra binti Ismailwi. And the last group members is Alia Nur Kristina binti Azizi. So, what you will go through in our presentation is first introduction of logical equivalence, content, example 1, example 2, example 3, and the last one is conclusion.
Assalamualaikum and hi, my name is Alia Nur Kisina binti Azizi, and today I will be explaining about the logical equivalence. So first thing first, what is logical equivalence? Logical equivalence is two statements that are considered to be logically equivalent if they have the same truth value. Logical equivalence consists proposition and conditional statement. Proposition consists tautology, contradiction, and contingency. And conditional statements consist inverse, converse, and contrapositive. As I said earlier, proposition consists tautology, contradiction, and contingency. Tautology is a compound that is always true regardless of the truth values of the propositional variables. And next, we have contradiction is a compound proposition that is always false. And last, we have contingency, where it is a compound proposition that is neither a tautology nor a contradiction. Next, we have conditional statements. To make it easier for me to explain about the conditional statement, we'll use this statement where if Amir is going to the field trip, then Amirah is not going. First conditional statement is inverse, where inverse is obtained by negating the antecedent and the consequent. From the statement that we used earlier, the statement will be if Amir is not going to the field trip, then Amirah is going. And for the symbol, we use not P implies not Q. Next, we have converse, where it is obtained by interchanging the antecedent and the consequent. From the statement, to converse it, it will become if Amirah is not going, then Amir is going to the field trip. And the symbol will be Q implies P. And for the last conditional statement, we have contrapositive, which is it is obtained by negating the both antecedent and the consequent by interchanging them. The statement for contrapositive will be if Amirah is going to the field trip, then Amir is not going. And for the symbol, it will be not Q implies not going. Next, my friend will be showing the examples of the questions regarding these topics.
Hi guys, it's me Nordini. So here we will do some exercises to check on our understanding towards this topic. So the first question is prove that P if and only if Q is logically equivalent to P implies Q and Q implies P. So let's look at this figure. So the truth value of P is true, true, false, false. However, truth value of Q is true, false, true, true. The truth value for P implies Q and we label it as 1 is true, false, true, true. However, the truth value of Q implies P and we label it as 2 is true, true, false, true. And 1 and 2 is true, false, false, true. So all of that is for right hand side. And let's settle down for the left hand side. P if and only if Q have the truth value of true, false, false, true. So let's look at the two second last column. They have the same truth value, so that we can conclude that two statements are considered to be logically equivalent since they have the same truth value.
Assalamualaikum. My name is Fatima Azahra binti Ismailwi, 2021491482. Today, I will present for the example 2. For the example 2, we can see here the statement is P implies Q, logical equivalent to not P or Q. So we can see here the truth table. P is true, true, false, false. Q, true, false, true, false. P implies Q, true, false, true, true. Not P, false, false, true, true. And not P or Q, true, false, true, true. So as you can see, not P or Q, the column not P or Q and P implies Q have the same truth value. So we can say the P implies Q and statement not P or Q are logically equivalent as they have same truth value for some combinations of P and Q.
Hi, I'm Siti Zaliha Najah binti Abdul Halim and I will proceed to example 3. The example number 3 is to prove that Q if and only if P are logically equivalent to the not P implies not Q and Q. So let's look at the truth table below. For the truth value of P is true, true, false, false, and for truth value of Q is true, false, true, false. From the right hand side, the truth value of Q if and only if P is true, false, false, true. So not P implies not Q and we label as 2. The truth value is true, true, false, true. And then the 2 that we label, which is the not P implies not Q, we conjunction with the Q, which is the truth value is true, false, false, true, and we label it as 3. And then we look at for the last column, which is we want to prove that the Q if and only if P are logically equivalent to the not P implies not Q and Q. So the truth value for all of the last column is true, so we can declare it as tautology. So our example 3 is proof that this is the logical equivalence. Thank you.
And as for the conclusion for this topic, we get to know what is logical equivalent, what is the proposition, and what is the conditional statement. And we also get to see how to solve the question regarding this topic. So I hope you enjoyed this video and you understand this video very well. I'm sorry if there is any mistakes from us, and thank you for watching.